when he starts his day. Okay, let's have another. Let's go to the next talk, Margaret Warren, about image snippets. Margaret, you got up in the middle of the night for this, yeah?
Yes. Hello.
Yeah.
Let's turn on allow. Start sharing. Okay. I hope this is on. Let's see. Hello. Okay. Hi. Yes, it's pretty early here. It's about 5 a.m. So, okay. Let me do this. Share the screen. Okay. We'll see if we have it. Do we have it? Let's see.
Yeah, that's good.
Okay, great. All right. Hi, I'm Margaret Warren, and I'm here with ImageSnippets. And we've been members of DBpedia for quite some time. And what ImageSnippets is a tool for image annotation research. And I'm just going to kind of launch right in. So what I want to talk about first is this distinction between scene graphs and named graphs and image graphs. And I'm going to go right over to the two image snippets to illustrate a lot of this. I picked some topics that have a crossover here in this image. You can see that it's often hard to distinguish between what is the most important thing you see in the image. You may want to name everything, but not everything is as important as other things. And so I'm going to come back over here. Okay. So, well, actually, one second. Let's go to this next one. Sorry. Okay, so I want to just point out that ImageSnippets is like a tool. It's like a loom that weaves annotations from images. It weaves linked data and images together and creates image graphs. Okay, let's see. Sorry, I'm not doing that so smoothly. Okay, so when we talk about scene graphs, name graphs, or image graphs, what I mean by that is that oftentimes when we look at what is actually in an image, what we can see in an image, that's what we would distinguish as being the things that are in a scene graph. And a scene graph might also show something like, the potted plant is on the floor. It would actually talk about the relationships, spatial relationships of things, how they relate to each other in the room and how things relate to each other. The way we deal with these with our data in ImageSnippets is that we save everything into triple store, and we also write everything as JSON LD and RDFA in images. So you can even see the source here, which would show all of the JSON LD and the RDFA, but then we also write everything to the triple store. So by doing this, the image itself becomes the subject of each, all of these triples, unless it's a region, which is of the triple. But all of this is referred to as the name graph, everything, including anything else that's in the image that you want to include, like the creator, the all of the EXIF data that you choose to include in the image as well. And our URIs can come from anywhere. They can come from on ImageSnippets if an image has been uploaded that way, or they can originate from any link, any URI anywhere that's on the web. So this would be about this image, and this would be a named graph about this image. And then what I call the scene graph is everything that's described in the image. So how do we get these these images on the, and I'm just going to find a simpler way to come back to that because I keep killing it. So, okay, so we call this like a human in the loop, making sense of the ambiguity, because there's ambiguity in all of these different methods. There's ambiguity in AI object recognition. There's ambiguity in classifiers and in the even in the named entity extraction. It's very difficult to know exactly what the subject is and how it's related. And so when we're building our triples by hand, we use these relationships, and these relationships are something we call LEO, which is the lightweight image ontology. And Leo, quick show here. This is a small ontology of just 11 terms that function as a glue, sort of how you might relate things that are in the image back to the image itself. And this is how we can sort on the images. And we can also make longer triples by extending the triples using which statements, which builds complex triple chains. But there's 4 ways that you can add on. One is that we can just auto extract the entities, and we often use DBpedia Spotlight for this. In this case, we're not right here, but let's just say that I want to talk about the cat that's back here. So I added that to my object list. That automatically mapped that term to a DBpedia entity. But I could have gotten more from that if I'd wanted to. Then other ways are we can simply just build the triple. This image has shows a fireplace, and sometimes we allow a lot of we can pick the most likely used item that's already a DBpedia to make it very fast. But if we want to, you can do a lookup, and you can look across as many data sets as you have selected. Sometimes this gives an awful lot of choice, but what we find is that you often cannot get anything that you might want to say about an image from just one data set, from just one public knowledge graph source. So not only that, but we can also create entities, which I'm not going to show. But if I want to also build a triple now about that, I'm going to say it has in the background, there it is, the little cat there. I added that cat before, and that is also automatically mapped to the DBpedia cat entity. So now I've built a very quick, let me just add this. We have 2 other methods. We can do, we use clarify for object classifiers. And what we do in this case is, because these choices are often very ambiguous and may or may not be something that you want to say, you find that if you can build triples about an image, you don't necessarily care that much about building keyword classifiers, but we do allow that to be added as a keyword, which can just stay. We create a triple for that in the data anyway. Then, so you can build these actually very somewhat rapidly for users to be able to build triples with precision. We also now have just added, this is very, very new, but we added an object recognition AI engine that we can add more models to. Our first model is very, very simple. It only knows about 100 things. It's like a little toddler, but we're going to add more to that. So you can see when we can say, well, there's the potted plant. I'm going to just add the potted plant and the couch, which is over off to the side over here, which is, it does the things it knows. It's pretty remarkable. And these are have been already mapped to DBpedia, so we just made a few triples. Oh, this should be couch, but anyway. Okay, so anyway, when we add those, this now gives us the ability to do all kinds of searches over this data. So we use our search tool. I'm going to come back to my talk because I can't remember where I keep putting it. So, for example, we can use the images here to navigate knowledge graph reasoning. So, to illustrate that, for example, I can do a lookup, and I'm going to show this one found the search by looking at the DBpedia, the SCOS concepts of architectural elements, and found, of course, our fireplace and our, this is one that shows more of the, how we can chain on, like Christmas lights are on the mantle. And then we have a tool which takes a few minutes to run, which is the Find Search Paths tool, which allows us to go through and see I don't know why I keep losing that. The chain of the triples and how we got to architectural element. And there's actually two different searches for architectural element because both DBpedia has the SCOS concept architectural element and Wikidata has that as well. And we do find that we get different searches, and that's one reason why we use DBpedia first in almost all of our entities. That's where that is because we can get the reasoning from both the SCOS concepts as well as from the subclass reasoning in Wikidata. So we can also get things like search for, this is just the search, this shows the difference between the search for the SCOS concepts, which has fireplace, depicts a fireplace, which is as an architectural element, whereas in Wikidata, it does not have fireplace as an architectural element, but it does have mantle. So that's why this one came up, and you find that by doing the Find Search Paths. So so then finally we have things like weaving equipment, and now if you wanted to do a search where you search for, say, the textile arts tool, I'm just searching right now over my images, not the entire set of images in ImageSnippets, and I can do a full lookup. And of course, there's my textile arts tool, and find the images. And even if I wanted to then combine that with, say, well, I would like to get the search, refine the search where I can find something that combines both a loom or a textile arts tool with a fireplace mantle. If I wanted to find something like that, I could. But these, we have a Sparkle endpoint, and we can also use our query our name graphs and even show the results as thumbnails. So if you want to look on for a certain property, you can do that. And then I just closed everything, but so anyhow, you could do all of those types of searches, and we search on or organize things by the, I'm going to just show one final search here, which is that, for example, if I do a bird search here, we'll show how well this works. You know, we've got about 3,400 birds here, but these will include Wikidata. I mean, they will include all of the DBpedia results as well. So let's just say everything is organized by their relationship. And then
Margaret, you're running into Q&A now.
Okay, great. All right, we'll just do the last search there and show even something that very ambiguous would not normally be found by any type of classifier or by the object recognition. And so this is why it's necessary to have like the humans in the loop who are able to help build these annotations and then build these image graphs, which are all of the images interlinked to each other. So thank you. Okay.
Okay, yeah, thank you. So we have
yes. Let me stop sharing. Okay, I think, right?
So there was a question from Nitisha. Do you perform image recognition on paintings? If yes, how successful or challenging is the task? So that's a René Magritte question.
Oh yes, no, we do for. I mean, we obviously have the humans look at the images right now. Our object recognition at the moment is very rudimentary. We just got started adding it into the mix. We hope to have it where we have a true human in the loop system where the AI is recognizing the objects, and then the user, the human, can refine that. And so, yeah, our current toddler system doesn't see anything in the paintings, but well, sometimes it can. If it's a really clear, like a person, it can. So, okay. But it's theoretically possible, yes, with the different models that we plug in.
Oh, okay. So now you have a lot of more questions. Do you annotate manually the image? Yeah.
Yes, so it's a combination. It's manually annotation, and we can allow all these other tools to speed up the process. Different versions, I'm seeing the questions now come up. Different versions of ownership. Yes, well, we can document a lot of provenance through it. We have not implemented a specific like, you know, W3C provenance strategy yet, but you know, because you can add the different triples, you can continue layering information, and the information doesn't just have to be things that you see in the image. It can be things that you anything about the image. So you can just keep layering those triples, because we also don't restrict anything to just being our Leo ontology. We also use schema.org, and you can use any other vocabulary that you might have. So if you have other provenance vocabulary, you can easily build the triples with each image. So.
Yeah, so I think this is a great strength of the system. So normally I have to say, okay, we are used now that there's a better than human image recognition. But in the end, I think these systems, okay, they can recognize a cat or a sidewalk or a traffic light, okay, but it's very specific, right?
Yes, they're really not they're not as, if you turn a lot of those systems, if you like turn like say it's a school bus, or maybe it's a person on the back of a bus. I think this is the most recent example I saw, which was one of those big posters on the back of a bus that has a person that's really huge, and the AI system in the car thought that it was an actual person walking, and so was putting on the brakes. So the object recognition systems are not perfect, and so there's something called active learning, which is where I think the attempt is to now bridge the AI engines that can work with a smaller number of images that are labeled, and they can work with, they don't need 100,000 images now that are labeled. You maybe only need, say, 11 or 15 or something like that that are labeled, and you can keep sort of feedback that loop into the machine where the human is getting more specific and specifying. I like to think of it like the way that you might talk to a toddler, the way you might like correct the toddler, and when the toddler says, that's a cat, and then the person says, no, that's actually a raccoon or something like that. So you correct the machine, and then the machine continues to learn and improve what it knows. So,
Yeah.
yeah.
So active learning would be good for your system because you
Yes.
have this human in the loop, and then you need to annotate fewer things. Yeah.
Yep.
Okay. Thank you, Margaret. We have to go to the next speaker.